Good morning, folks. We're watching a towering plasma filament complex on the incoming limb here in the opening. We'll hit solar storm impacts, more solar flares, volcanoes, and electrical conductivity of the lower crust. But we are starting with the last 24 hours on our star, and we find several eruptive events took place on the departing limb, including an M5 solar flare this morning. You will see those blasts, including a consecutive release over there on the right. Active regions still saying goodbye as it turns away. The second impact in the solar wind, which we'd been waiting for, occurred very weakly overnight, but was still able to produce a level 2 geomagnetic storm. This is relevant for atmospheric conditions, but is unlikely to have produced any significant technological impacts. Luckily, both aspects of the 1-2 punch in the solar wind were faint. Taking a bit closer look at the solar flares and the departing sunspots, they release some potent CMEs, but they are not directed at Earth. Pretty much headed out 90 degrees ahead of our orbit. That filament is now the top watch as it turns in to face the Earth. Let's move on to volcanoes. This is the second paper in the last few months to definitively say that climate models have no way of appreciating the impact of major volcanic eruptions in the future. It is absolutely true that we have been without major eruptive activity for quite some time. Even the Tonga eruption wasn't as big as what we're overdue for. And just that one event could wipe out every ounce of the so-called global warming in a matter of days, and it's only a matter of time. Lastly, folks, we are once again highlighting what I consider to be an enormously underrated field of science, covering the electrical conductivity of the lower crust and upper mantle low velocity zone region. This one focuses on the lower crust and details how they can better understand those electrochemical profiles of the rock. This, of course, is critical because the crust is only locked to the mantle via a delicate balance of temperature and electrical condition, a thermoelectric equilibrium, where even modest solar storms can induce currents into the mantle, and then the biggest blasts, like the ones we expect in the near future. Those currents could break that equilibrium and unlock the crust from the mantle, the height of the geophysical disaster in the catastrophe cycle.